Hello everyone. Before starting this lesson, try the warm-up. A landscaping company charges $10 per square foot for installing interlocking stones, plus a $50 delivery fee. Write the cost as a function of the area to be paved. And then part B, rearrange the equation to solve for the area to be paved. Pause the video and see what you can come up with. Okay, so the cost, I'm using C to represent that, and for the area, I'm using the letter A. To calculate the cost, well, it was $10 per square foot, so 10 times the area, plus a $50 delivery fee, so plus 50. So the cost is equal to 10 times the area plus 50. That's my cost as a function of the area. Now, rearranging the equation to solve for the area to be paved, I'm isolating A. So if I take my original function, C equals 10A plus 50, I'm trying to isolate A, so I've got to subtract 50 from each side, which gives me C minus 50 equals 10A. To solve for A, I've got to divide by 10, do the same thing on each side. I end up with C minus 50 divided by 10. So to calculate A, it's the cost minus 50, whatever that is, divided by 10, and that will get you the area. Now this algebra that we did here to rearrange an equation, we're going to actually use that in today's lesson. Today we're talking about inverse relations. So we're going to talk about what that is, and then how we can determine what the inverse of a function is, and then investigate its properties. So first, some terminology. The inverse of a function is the reverse of the original function. The word inverse just means you're reversing, or you're doing the opposite, kind of. It undoes what the original function has done, in other words. And I will clarify this with the next example, but some notation first. If the original function is f of x, the inverse of that function is written this way. F to the minus 1, it looks like, of x. This symbol here means the inverse of the function f. So that's notation. The inverse of a function is undoing what the original function has done. And now let's get into an example. So let's say this was our function. F of x is equal to the set of all these ordered pairs. 1 minus 2, 2 minus 3, 3 minus 4, and 4 minus 5. If I graphed this function f of x, it would look like this. I would have a series of 4 points on the grid. So this is f of x. Now if I wanted to find the inverse of f of x, all I have to do is, for each point, switch x and y. So, in f of x is 1, y is minus 2. In the inverse of f of x is minus 2, y is 1. See, I switch x and y for each ordered pair. So every single point on the function f of x has its input and output reversed. That's what inverse means. And if I plotted it on a graph, it would look like this. So f of x is here, the inverse of f of x is here. Now something I would like you to notice between a function and its inverse is that it's a mirror image across this line. And that line is y equals x. So if you want to think visually about an inverse of a function, you can just draw the line y equals x, and you can use it as your mirror line. Every point on the function has its mirror image on the other side, and that's the inverse. So you can think of it visually like that, or you can think of it as swapping x and y. Either way, you're going to get the inverse of your function. Now let's try this next example together. F of x is equal to x squared plus 2. Part A asks for the equation of the inverse. Now, before I proceed, sometimes it's helpful when you're trying to find the inverse to not write your function in function notation, but rather to write it with a y here. So we would end up with y equals x squared plus 2 as the function. So if we're asked to find the equation of the inverse, well, remember in the previous example, I told you to find the inverse, you swap the x and y values. So I can do the same thing. If I swap x and y in the equation of the function, I end up with x equals y squared plus 2. So this is the beginnings of the equation of the inverse of my function. I've just swapped x and y, that's it. However, normally when we write an equation to make a graph, we have it in the form y equals, not x equals. So I'm going to have to do some rearranging here. So if I'm trying to isolate for y, first I'll eliminate this plus 2 by doing the opposite, minus 2. So if I do that to both sides, I end up with x minus 2 on the left and just y squared on the right. But I still haven't solved for y. This is y squared. So the opposite of squaring is square root. Now, just be careful here. I'm not just going to take the square root. I'm going to take the positive or the negative square root. Let me just explain that by going off on a tangent here. Here's an example of this idea of plus or minus square root. So 5 squared is 5 times 5, that's 25. Negative 5 squared is negative 5 times negative 5, that's also 25. So if I had an equation that said x squared equals 25, well, is my answer 5 or is it negative 5? They both get me 25 when I square them. So x has to be either positive 5 or negative 5. That's what this symbol means. And that's what I'm saying when I say when we take the square root, we have to take the positive or the negative square root because both of those answers are correct. So back to the example, the equation of the inverse of this function, I swap x and y, I isolate for y, so now I know that the inverse of the function is the positive or the negative square root of x minus 2. So we finally got part A, we got the equation of the inverse, here it is. Part B, graph f of x and the inverse. Well, let's start with graphing f of x. It's x squared plus 2. If you're not sure how to graph a quadratic function, if you've forgotten since grade 10, just start by picking values of x and figuring out what y would be. Then you can have a series of points and you can draw a curve through the points. So let's start with 0. If x is 0, x squared is 0, add 2, that's 2. So when x is 0, y is 2. Now we can change the value of x. Now x is 1. Let's try that. When x is 1, x squared is 1 squared, which is 1. Add 2, that's 3. So when x is 1, y is 3. Now let's keep going. X is 2. 2 squared is 4, plus 2 is 6. So when x is 2, y is 6. Let's go in the negative direction. What if x was negative 1? Well, negative 1 squared is negative 1 times negative 1, which is positive 1. Add 2, that's 3. So when x is negative 1, y is 3. And we can keep building our graph, and we end up with a parabola, and it looks like that. So I've graphed f of x. Now I need to graph the inverse. Well, that's scary, because how do I graph this crazy looking thing, the positive or negative square root of x minus 2? Well, I could graph it the same way I graphed the other one. Pick values of x, do the calculation and find what y is, and then plot the points. Or I can remember the other thing in the previous example that I talked about. where I can draw the line y equals x, and I can draw the mirror image on the other side. So the vertex of f of x is up 2 units from the line. Now a mirror image would be over here. This point would reflect here. This point would reflect here. This point would reflect here. And this point would reflect here. So now I can see the inverse of my function is this curve over here. So we found the equation of the inverse. We found the graph of the inverse. I hope you can see, if y equals x is the mirror, that this is a reflection of the original function. This one opens up, this one opens to the side. Now let's talk about domain and range for each. We can find the domain of f of x is an element of the real numbers. There's no restrictions. Y is an element of the real numbers, but the lowest it can go is 2. So y is greater than or equal to 2. Now look what happens with the inverse function. X and y are basically switched. The domain and range are switched. The restrictions are just switched. It all just switches, x and y. So if you can find the domain and range of the function, you can easily find the domain and range of the inverse without having to do much thinking. You just swap the x and the y, and that changes from domain to range, and you've got it. Now, one last thing I want to point out about this example is that although f of x is a function, the inverse is not a function. Remember that vertical line test. As you pass a vertical line through the graph, it's going to contact more than one point at a time. So this tells me that this is not a function, even though this is. So the inverse of a function is an image of the original function reflected through the line y equals x. And the inverse is not always a function itself. Now this is an example I'd like you to try on your own. Graph the inverse of the function, and then determine the domain and range for both the function and its inverse. We're starting with just a graph. I don't have an equation for this one, so you're just going to look at this graph of f of x, and then you're going to try to graph the inverse. And once you've done that, determine the domain and range for both. So pause the video and try this question on your own and see how you do. Here's my graph, and I'm giving you a little insight as to how I found the graph of my inverse. For example, this point on my function has coordinates -4, 4, x, y. If I switch x and y, it becomes 4, -4, this point down here. I can do that with each point, like this one. Has coordinates 9, -2, x and y. Switch x and y, it's now -2, 9, this point up here. So you can do that too. You can find points on your function and just switch the coordinates around. Switch x and y, and then you get the coordinates of that same point on your inverse. And if we look at our domain and range of our function, the lowest x can be is -4. The highest x can be is 9. So that's where the restriction on x came from. Now look at the y values on our function, f of x. The lowest it can be, the lowest y can be is -2. The highest it can be is 4. That's where the restriction came for y. Notice if I do the same thing to find the domain and range of my inverse, well, the restrictions are just swapped. Okay, so domain and range, switch to get the domain and range for the inverse. All right, we'll finish off with writing the inverse given the equation of the function. So here I have f of x equals the square root of x minus 2. Find the equation of the inverse. Do the same thing with this function. Find the equation of the inverse. So remember, you swap x and y, and you isolate for y. Pause the video, see what you can do. Here we are. Swap x and y, so x equals the square root of y minus 2. If you want to do the opposite of square root, that's squaring. So if I square both sides, I end up with this statement here. To isolate y, I have to add 2. So that's where this comes from. So the inverse function is x squared plus 2. Over here, swap x and y. I want to isolate y, so I'm going to add 5, end up with x plus 5 over here. Now I've got to do a little work to isolate y here, and I'm kind of skipping a step here. I'm showing a shortcut here. Let me explain the shortcut. Imagine this equation. 2 is equal to 10 divided by 5. 10 divided by 5 is equal to 2. That makes sense. But if I wanted to rearrange this equation to isolate 5, well, what is 5 equal to? Is it 10 times 2? No, that's 20. It's 10 divided by 2. So if I know this, if this makes sense, 2 is equal to 10 divided by 5, and 5 is equal to 10 divided by 2, well, I can just easily rearrange. It's the same thing here. X plus 5 instead of 2, 2 instead of 10, y plus 3 instead of 5. Here I was isolating 5. It was the top divided by the thing by itself. Here, the top divided by the thing by itself. 2 divided by x plus 5 is equal to y plus 3. So, these two lines are just like these two lines on my side note here. If that doesn't make sense to you, just pause the video right now and ask me to explain it further. Otherwise, keep going. I've rearranged my equation so that I have y plus 3 is equal to 2 divided by x plus 5. Isolate y by subtracting 3, so I end up with this. So the inverse of the function is 2 over x plus 5 minus 3. Now do the same thing with these functions. Find the inverse. Pause the video and see what you can do. For the first one, swap x and y, I end up with this. Take away 1. Here, I'm multiplying by negative 2/3. So the opposite of that would be multiplying by the reciprocal, negative 3 over 2. So that's where this came from. And for this next part, swap x and y again. You got to add 3. You got to divide by 2. And you got to take this positive or negative square root. That's where that came from. Now some of these are kind of tricky to find the equation of the inverse, but it is doable with practice. Now for those up for the challenge, you can try this one. A simple way to convert Celsius to Fahrenheit is to double the Celsius, then add 30. So write this rule as a function, write the inverse as a rule and a function, and if the temperature was 70 degrees Fahrenheit, what was that in Celsius? So if you are up for the challenge, you can pause the video and try this question, and then I'll take it up in a little bit. If we're doubling the temperature and then adding 30, that's this, 2x plus 30. The inverse would be this, x minus 30 divided by 2. So if we're given the temperature in Fahrenheit and we want to turn it into Celsius, that's the inverse of this function, because this describes this. To convert Celsius to Fahrenheit, if we want to convert Fahrenheit to Celsius, that's the inverse. So we're going to use this, plug in our temperature in Fahrenheit, and we get 20 degrees Celsius as the equivalent temperature in Celsius. The big ideas from this lesson are, if you want to find the inverse of a function, you swap x and y. They trade places, and then you isolate for y. That gives you the equation of the inverse. And if you're going to look at a graph, it's a mirror image reflected across the line y equals x. And you can find domain and range of your function and just swap x and y to find the domain and range of your inverse. There's a practice sheet, so try the practice. If you come into any issues, let me know, and I'll do my best to help.